Use the product rule to find the derivative of the following function. All right, we can do that. This root x is not our friend. I'm going to rewrite that as x to the 1/2 so that the power rule can help us, times 5x to the 4th. So you'll recall the product rule tells us that the derivative of something times something else is first d second plus second d first. So we write the first part, which is x to the 1/2, and that's multiplied by the derivative of the second piece. So the derivative here would be 4 times 5 is 20, x to the power drops by 1, plus, now we go the other way, second d first. Second part is 5x to the 4th, and the derivative of the first part is 1/2 x to the minus 1/2. Technically, you could stop there, but please don't. Let's get this cleaned up. First term, we get 20 x to the, what? We add these powers, so we have 3 plus 1/2. There we go. And for the second term, 5 times 1/2 is 5 over 2, or 2.5 if you like. And x to the 4 plus negative 1/2 is x to the 3 over 2 again. Or sorry, 7 over 2 again. Well, these are the same power, which means we can and should add them together. So instead of 20, think of that as 20 over 1, which is the same as 40 over 2, x to the 7 over 2, la 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 la, just getting a common denominator. 40 halves plus 5 halves is 45 halves x to the 7 over 2. Again, we could have expanded this before we started the derivative. Well, let's just do that real quick and see if it would have worked. If we multiply that out, we have x to the 1/2 times 5x to the 4th, which would have been 5x to the 9 over 2. If we'd done the derivative straight from there, we would have gotten 45 over 2, x to the, reduce this by 1. Lo and behold, it works. So the product rule is working, even though for problems of this category, it's a little too much work. And realistically, if you had to do this, if they weren't requiring us to use the product rule, we would just clean this up and then go on.